All right. Now, transportation is responsible for nearly 30% of the EU's total CO2 emissions. It's actually the only sector in which emissions are still higher than they were in 1990. This heavy reliance on fossil fuels to move people and to move goods poses a huge challenge for decarbonization, especially given that the European Green Deal aims to achieve a 90% reduction in transport-related greenhouse gas emissions by 2050. Our next session will explore the technologies transforming the industry, from electric planes to carbon-free ships, and back on Earth, how we accelerate the mainstreaming of EVs, a little bit about what we were just talking about. So joining me on stage, please welcome Niclas Dahl, Managing Director for Oceanbird, which develops wind propulsion for commercial vessels, Dirk Hoke, President and CEO of electric air taxi company Volocopter, and Julia Poliscanova, who is the Senior Director for Vehicles and E-Mobility Supply Chains at Transport and Environment, a research and policy group advocating for clean transport and energy within the EU. Welcome, everybody. I will now sit down. All right. Well, thank you all so much for being here. Dirk, let's start with you. Volocopter. Tell us a little bit about flying vehicles. Tell us about what you're making. And how do they fit into this bigger picture, right? This idea of sustainable urban transportation. Are they playthings for rich people, right? Which might be what someone would think when they hear about this idea. Tell us a little bit sort of more about that.
Yeah, we built fully electric powered planes, aircraft. We didn't have found a good name for it. We still call it electric flying taxis, which is not the right word. We start with a two-seater, 18 rotors and motors, fully redundant, 100 times to 1,000 times safer than a helicopter, and being able to fly at the beginning in city environment 20 to 30 kilometers, one pilot, one passenger. That's not a business model, but it will open up the market. This is more like when Tesla started with the Roadster, when there was no infrastructure. So this is a similar case, but in a few years, you will see many applications. Here you see a lot of our flights. Lastly, in summer in Paris, over the Chateau de Versailles, East River, New York, last year, November. So we're flying everywhere since 2016. We're showing that also to overcome one of the other big hurdles, which is public acceptance. As we heard for the first car, for the first aircraft, for the first helicopter, always the same. Who needs that? This is only for the ultra-rich.
Right.
Kaiser Wilhelm said, this will never replace my horses. So we know where this ended. It all starts with rich people, business people going to everyone, and this will be exactly the same. And I guarantee you this will happening much faster than you think. So we would be certified this year. We had some financing problems. As you know, the market is quite difficult. So we aim for certification mid of next year. And we will be still first in the market to start commercial operation. I think what you can see is the narrative repeats, because what you heard in the panel before, you heard about electric cars and how difficult the story, and it's still slow, and we talk about 15 years, but look where China is now. And Chinese government decided this year in March to put it into the national strategy. So they call it low altitude economy. It's the first time they opened the private airspace. And you can count the time now, 10 years from now, you will see exactly the BYDs happening again. So the question is, will we be having an Airbus and Boeing still, or will it be a Chinese economy at that time?
And when you think about sort of making flying vehicles, right, an everyday sustainable model of transportation, right, for someone, what are the primary technological challenges in actually making that happen, right? And sort of scaling the technology and taking it from, something for the rich people, right, the business class, to the everyday consumer, the everyday user.
The only remaining challenge is the battery. It's a very simple aircraft. It's same as for electric cars. Maintenance is a friction of a combustion-driven vehicle. And the reliability, as I said already before, we will be certified same as an Airbus A320. So we have to prove that we can have no incident in 1 billion operating hours. So it's absolutely safe. Balance of scale applies. Normal commercial aircraft you produce in the hundreds. Business jets also in a few hundreds. These will be thousands. But already when you get we did this for our current model. Once you cross 500 aircraft per year, you can already reduce the price by more than half. So if you go into the thousands, a vehicle that you will see, a 5-seater in 5 years from now, will be around 1.5 million, maybe below that even, on price to the operator.
And what about energy efficiency, right? I mean, that's one of the primary reasons we're here today. So how do you minimize the environmental impact of a vehicle like this?
So the beginning is, you see, it's easy to make something fly, but it's very difficult to make it certify. I think this is where most of the people struggle, because they think they take off-the-shelf components and they make something fly and then they can certify. That doesn't work like this in aerospace, unfortunately. There are a lot of rules from FAA and EASA how to certify a vehicle. You need to have a design organization approval, and you need a production organization approval. It takes a lot of things to do before you can even go close to certification. So this is one of the biggest hurdles. Then of course, you need the public acceptance, you need the infrastructure. So it takes time to build that up. And then one of the biggest hurdles will be the integration into air traffic control. Today, I don't know if you know, the air traffic is controlled by humans in sectors. This is still the case for 25,000 commercial aircraft. Airbus and Boeing want to grow to 46,000 aircraft, but they cannot do this because humans cannot control these amount of aircraft. So we need digital transformation, but there's a high resistance to change, and it takes really ages to change that. So going from 25,000 to 46,000 aircraft and putting now thousands of drones on top is, of course, a major challenge.
Right.
This is why we still fly below the controlled airspace. But the major step forward to scaling will be the integration into air traffic control.
Got it. Fascinating. And we'll talk more about this in a little bit. Niclas, I want to turn to you, Oceanbird. So wind-powered cargo transport. So explain that a little bit to everybody and tell us sort of how does that compare to conventional shipping, right? Sort of what goes on right now, particularly in terms of emissions and environmental impact.
Yeah. No, but using wind in marine is not really new in that way. I mean, we did it thousands of years ago. And I think what now coming up is more push for, from legislation point of view, in order to reduce emissions, but also reduce the cost regarding transportation and different things. So what we are doing is that we are providing wings for commercial ships. They are very big. It's more like an airplane wing than a traditional sail. So we did the opposite from Bertrand. We went from the shipyard to the airplane industry instead, and put it on that part. So what we're doing then, in order to, so most ships, they will then be on hybrid solution. And here you see what it looks like in practice.
That's very cool.
So we go on a hybrid solution, which means that you put 1 or 2 different wings. You will still have an engine. That will still be necessary for legislation, because you need, from safety reason, to be able to go out of storms. You will have times where you don't have enough of winds and so on. But I think this is really the future to utilize this, because you will save quite a lot. One of these wing, I normally hate to talk about percentage, and everyone is pushing me that how much percent are you saving? But one of these wing, if we take a car carrier, take 7,000 car, it saves around 10%. And this is an industry where you fight for every percent. I mean, it's quite massive with one wing. It's 600 tons of oil that you're saving every year. So of course you have a good business case in that way, both from an economic point of view, but also from a sustainability point of view.
Got it. And same question as I asked Dirk around sort of scaling, right? This is a fascinating idea, a compelling idea. What are the primary challenges in actually scaling this technology?
I mean, it's to manufacturing this is big structure and so on. So of course you need a lot of investments in order to do that, to set it up. Mm-hmm. So that's one part of the main challenges, I would say. But I think, I mean, in the industry, we are not alone in the marine industry to utilizing wind. I mean, there are others, different solutions for this as well. And I think, I mean, now we're past the point where will wind play an important role for future sustainable shipping? Yes, it will. What technology? And that will then depend on who is the best one to scale this up, who has the best service network around in order to service these ships around the world. And I think that's where we come in. We are a small company today, but we are owned by Alfa Laval and Wallenius, which means that we have the infrastructure, we have supply chain around the world that we can utilize. But I would say that is the main challenge.
Yeah. And what about the trade-offs? So I believe, this concept of sort of a wind-powered vessel, right? It would be slower than more conventional options. Is that right?
No, that's actually one of the misconceptions. I mean, what you can do normally, if we talk about a hybrid solution where you have one wing, we will optimize it depending on the speed that you want to drive your ship with. Then, of course, the slower you go, the more wind will not come from the front, which is normally very good. So you will get more power if you have less speed. But we are not dictating the speed, so we can still utilize it. But the faster you go, it's like when you go with your car and you take out your hand. It's very rare that you feel the wind coming from the side or behind you.
Right.
So it will really come from the front. So the slower you go, the more power you would get for it. Then, of course, if you take a fully sailing ship, I mean, that also depends on the wind situations and so on. So it can go even faster or it can go slower.
Do you have any sort of examples of this being deployed in the real world already that you think are sort of compelling for people to sort of help conceptualize how it's used?
Yeah, I mean, it's already 100 ships with different solutions out there utilizing wind. We are building up the first installation now on a land based in south of Sweden. And we are doing the first installation on Wallenius Wilhelmsen vessel beginning of next year. So that's an existing vessel that is already trading today. So when that has been now prepared, so when it comes back to Europe, we will place a wing on to that one.
Got it.
Yeah.
Very, very cool. Thank you. And Julia, let's turn to you for a little bit and talk about EVs. I thought that previous discussion was really interesting and sort of teed you up very nicely, actually. When you look at sort of the biggest barriers to accelerating the adoption of EVs across the EU, what stands out to you? What is sort of getting in the way of this technology being, scaled and adopted by consumers more broadly?
Yes, no, great question and really great to be here. Hello, everyone. Really excellent venue, by the way. We don't get venues like that in Brussels. Maybe first a really quick word on transport and environment, just for those that maybe don't know us. So we as TNE today are Europe's largest green transport group. So just more generally to explain what we do everything from the Rocky Mountain Institute kind of work, so research analysis, being a think tank, to more Greenpeace type work, so more pressure work. We work a lot on policies. So we just heard Sandeep previously talking from Uber's perspective. In fact, we partnered with the Sierra Club in the US in 2019 and ran a campaign to encourage, or shall I say push, Uber and Lyft to electrify in their cities, and following that, there was a great commitment. So that's type of work we do as TNE. Now, going to electrification. Generally today, we see a transport story really as an energy story. If you look at cars or trucks, the best technology out there to decarbonize is battery electric. When we look at ships or planes, there's definitely a lot of electrification story, but we also look at green hydrogen fuels in those sectors. So it's really an energy story. E-mobility or electric vehicles is the biggest today opportunity because cars is the vastest bulk of emissions in the transport sector, which are still growing, and the technology is already there. But the reason why they haven't been taken up as much, in our view, is not because people don't want to buy them or because there are no chargers, but simply because we still lack affordable mass market models on the market. As soon as you bring a car which is in the right price segment, so 25,000 euros, people buy it without actually thinking so much. We saw this in France, where they brought a program called social leasing, where people could rent or lease a vehicle for 100, 200 euros a month. It was oversubscribed 5 times in 1 month. So the demand is there. The problem is, in our view, some of the largest car makers out there today, certainly not BYD, but European Western car makers that are simply too late So first of all, they're too late to the story. So the technology and the scale is not there because they're still focusing too much on diesel and petrol. But number two is also they quite often prioritize the short-term profit view. So they sell you a bigger, more expensive EV as opposed to really going for those affordable vehicles. Affordable EVs are possible. Battery prices are down. Raw material prices are down. There's really no reason. And we will see complete change in the market in next year. So in 2025, if you're in the market for an electric car, buy one. There will be plenty of affordable offers. A dozen of European affordable electric cars are coming. They're coming because of European regulations. So hopefully it will be a good story next year.
Well, and how does infrastructure play into that story, right? Because I know, I live in the United States, I live in New York, but I know that in the US as well as in the EU, there's a lot of conversation about actually changing infrastructure to support more widespread adoption of EVs. Sort of, what does that look like to you? And are there any, approaches you would love to see or anything happening now that we should know about that's actually accelerating how that infrastructure is being rolled out to support, hopefully that really good story in 2025 and beyond?
Yes, absolutely. Charging infrastructure is, of course, key to that. And I would highlight maybe three different parts of that we need to do. The first and most obvious one is to have the minimum sufficient public charging network, right? So wherever you are, you have enough chargers around you to drive wherever you need to go. And this is one piece of the puzzle that is genuinely being solved. Yes, if we were speaking here in 2019, it wasn't there. But in 2024, it is a success story. And if you just look around you in your city, you will see a lot more chargers. We now have a European law that requires every country to establish enough public chargers compared to the number of vehicles there, and also make them all interoperable or easy to use. So that's number one, and that's really been solved. The second big piece of this is private charging, or charging you do at home. And I find this one still not fully there, because we still just have, and I'm personally living through this right now in Brussels with my son Dirk, not sure what's the right expression, but the owner of the building, that the bureaucracy is just surreal to install that charge. And we are owners of the flat, we still can't do it. So you need to go and really work with homeowners and housing associations and some of the the grid connectors around your private buildings to make sure that those of us that live in flats or houses find it much easier to install those chargers. There are good practices. In France, for example, there's great stuff they're doing there, so we can do that. And the final, maybe more positive story connecting this also to energy and, for example, Octopus Energy is what also Stella mentioned actually earlier, the vehicle-to-grid story. So there's an issue. We have electric vehicles, they're there, we need charging for them. But electric vehicles are also a huge opportunity. Just like any car, they're stationary 90% of the time. So 90% of the time, it's a battery on wheels. And if only we can really facilitate via regulations that it's easy to use. There can be 1 million drivers around there providing flexibility to the grid and charging when there is too much cheap electricity. Today, we estimate that by 2030, 10% of Europe's energy can be provided by electric car and truck drivers. So it's huge, but it's not happening because there are some barriers in laws. For example, not all cars today are bidirectionally capable. So if we make sure that all car makers do it as a standard, we will see it at a much larger scale than today.
Now, coming from where I sit again in the US, we certainly look at the EU as a leader, right, in setting emission standards for vehicles. So what lessons, if any, do you think the world can learn from sort of how the EU has tackled, emissions regulations, the rollout of EVs, infrastructure, all of that?
Right, so there's definitely some lessons, but what's happening right now is also probably a lesson of not to do.
Yeah.
Look, the most important is to have long-term vision and a long-term target. Given the 2035 target in Europe, the target to go full zero emissions or full electric for cars, was really revolutionary. It's not just about climate. In Europe today, it's the main industrial policy. We don't have subsidies like in the US. We don't have the same way of regulating than in China. But creating that market created an amazing opportunity. And that's why today in Europe, we have around 50 factories factories planning to produce batteries, for example. That's why we have so many businesses around that, Octopus being one of them. There's a lot of ones in charging. So it really creates that signal. So long-term targets are important, but they're not enough. In addition, you need to have regular targets to get there. Because if you only have a target 20 years away, no one will do anything until 2 years before the target. So what the EU has also done is 5 yearly targets. That's why so many of us saw so many electric vehicles in Europe in 2020, actually, because that was the first major CO2 emissions target. But there is also many lessons of what not to do. So what we're doing right now, because the target next year is approaching, it's a bit difficult. Some of our car makers are behind because they did not invest in time. They are lobbying to weaken those targets. And a lot of calling it a crisis. It's not a crisis, it's an industry in transition. It won't be like this, it will always be like this. But what we're doing now is questioning those targets. And that is causing a lot of investment uncertainty. So major battery executives in Europe are saying, I'm not sure if I will expand in Europe, because if Europe takes away that signal, what's the point? I will import those batteries. So targets and long-term vision important, but it's as important not to question them every year something goes wrong.
Right. And a question for all three of you as we sort of come to our final few minutes here. You know, the EU has this goal, right? Carbon neutrality in the transport sector by 2050. How optimistic are each of you about the EU reaching that goal? And when you think about the most critical steps from the point of view of your specific industry, sort of your niche, you know, what needs to happen to stay on track? Maybe, Niclas, if we can start with you and go through the group.
No, but for the maritime industry, I think we've seen it's a quite traditional industry in general, and it's been very slow. And I think that has been, and they've been burning a lot of fossil fuel and so on. What is now happening, there is a lot of ETS, I mean, emission trade schemes, and also different legislation coming in on CO2 and so on. So the industry is really changing, and I think what's really important. I'm quite sure we will reach very, very far, and I think what's super important to say is also that there is not like one silver bullet that will fix all of these things. So we need to work on everything. I mean, waste heat recovery in marine industry is a huge thing. You have the future fuels and so on, and then if you combine that with different wind solutions and so on, we are getting really, really far into that part.
I'm still not so optimistic because I think we are too slow. We are too bureaucratic. We work too much with penalties than incentives. And I think we could do much more if we would put the right incentivization. I think our industry will struggle the next years, what we have seen on the panel before. The next years, if you see the amount of super cool cars arriving at low price from China, we were not prepared for that, or we were sleeping too long, and we will pay for that. And I think maybe that's also the warning signal that we need to change, because we do more of the same. We try to think electric vehicle infrastructure same as we did for combustion engine. I'll give you an example. I drive a full electric car. Too expensive compared to what you see from China. And when I drive, I was driving to Frankfurt, only 115 kilometers and back. I couldn't make it. So I was aiming for an exit, going to a charging station. There was a nice sign saying charging station. I went there. It looked like, first of all, you pass the gas station. You go to the dark area where the trucks are parked. You have no lights. You have no cover. It's raining. And then I get out, nice charging station from EnBW, but unfortunately not connected. So I did this 3 times along the highway, and I was running a bit low on energy. So this is, first of all, it takes too long to connect them. We can have much more charging stations. And it's also a total different approach. I went to China from Shanghai to Chengdu. We stopped at the highway station. It was a full big building, hundreds of charging stations. You go out, you go roller stairs up, you have a food court, you can have a convenience store, you buy everything you need, you get in the car and continue.
Sounds lovely.
So why do we think electric cars have to be operated like combustion engine cars?
Right.
Yeah, so we have to think radically different in order to achieve our goals and also to wake everyone up.
Really interesting. Lastly?
Yes, so maybe briefly from my side, I'm a lot more optimistic about road transport and actually electrification. The technology is there. Ultimately, it's still a car. I hope they will also be smaller, by the way, in the future, but that's maybe a discussion for another panel. Where I'm a lot more concerned, and we are a lot more concerned as TNE, is actually the aviation and shipping story. We absolutely see some progress in maybe the shorter trips, but long-term global trips will require some of those renewable synthetic fuels, synthetic kerosene, synthetic ammonia, and we really don't see that happening fast enough. So for me, policymakers and everyone really needs to focus in the coming years a lot more on aviation and shipping. More broadly, our vision or our approach of governments to infrastructure is really wrong. We still live in the 1980s mantra of road building, airports, rail. Rail is great, by the way, but it's a very old school approach. Transport decarbonization is all about energy, so the money should be going to green energy, grids, etc. And if we don't switch that, we won't get there fast enough.
All right, fascinating stuff. Thank you all so much. Round of applause. Thank you.